Example 13. A piece of copper of mass 100 gram is heated to 100 degrees Celsius and transferred to a well-lead copper can of mass 50 gram containing 200 gram of water at 10 degrees Celsius. So we see that there's a hot piece of copper at 100 degrees Celsius. It's going to put inside a cold water. The water initially is at 10 degrees Celsius. Both the water and this copper can will also be 10 degrees Celsius, because this copper can and this water has been together for a long time, so they will be at the same temperature as 10 degrees Celsius. So eventually when you put the hot piece of copper inside the water, eventually they all will reach a new final temperature. Okay, ignoring heat loss to the surroundings, calculate the final steady temperature of the water after it has been stirred. And if we assume no heat loss, if we ignore heat loss to the surrounding, that means all the heat that is lost by the hot piece of copper will all go into the copper can and the water. None of it is lost elsewhere. Okay, we are given specific capacity of copper as well as the specific heat capacity of water. So all these are the small c. Okay, so first, the heat loss by the copper mass. This is the very hot copper mass. Okay, this heat loss by the copper mass will go to heat gain by the copper can, okay, which is the container, which is initially at 10 degrees Celsius, and plus the heat gain by water. Okay, take note that in this delta theta, we use initial temperature minus the final temperature, because this is heat lost. Okay, the heat loss, there's a temperature drop, so the initial temperature is higher. This is different from the previous example where the change in temperature, we use the final temperature minus the initial temperature, because this is heat gain. In heat gain, the final temperature is higher, so we take the higher value minus the smaller value. Then equal to heat gain by the copper can. This time is heat gain, that means the final temperature will be higher, so the change in temperature, in order to get a positive number here, we will be using final temperature minus the initial temperature. Then the heat gain by water, same thing, because it's heat gain, the final temperature is higher, so in the delta theta, we use the final temperature minus the initial temperature. Okay, then we sub in everything and calculate. We'll get the final temperature as 14 degrees Celsius.